everyone, I am Chow Xin, and my subtitle is Determinations of the Optimum but Necessary delivery role in Johor using dynamic programming and genetic algorithm.
During the movement controls of the periods, the demands for plant gradually increased because people began to have more interest in gardening, and interactions with plants can reduce their stress. Besides, COVID-19 also accelerated the development of e-commerce in Malaysia. These conditions lead to the current transportation systems being difficult to efficiently arrange the delivery route between many orders. So, the logistic transportation route system is extremely important in the logistic and delivery phase. It can reduce delivery costs and time, and even improve the efficiencies of transportation service and the company's key cooperative business. Delivery time is the most important consideration in logistics. This is because if the product cannot be traversed on time, the satisfaction level of customer will be decreased. And longer distance transportation is associated with higher logistic costs. And certain products such as plants will be damaged due to the long shipping times. Besides, most of the drivers plan the delivery route based on their own experience. This will cause the driver to miss the road or take a longer distance travel. Optimization algorithms such as genetic algorithm and dynamic programming are the popular method for determining the shorter route. Genetic algorithms is the most effective algorithm in large-scale problem and can obtain the optimal solutions within reasonable times. While dynamic programming involves explanation, thorough and execution time requirements and can only handle the small-scale problem in less than 20 cities. So, this is in interest in applying genetic algorithms and dynamic programming to determine the optimal delivery routes for the plant necessary company in Johor with minimum total distance traveled and time spent. There are four objectives of study. This data involves primary data and secondary data. Primary data were obtained from time courier necessary company and passed on the provided data by the company. The total distance and time spent in three different time periods of 8 a.m., 1 p.m., and 3 p.m. were collected from the Google Map. These data sets were used to study the optimal delivery routes for the plant necessary company. Besides, these data sets were obtained for TSPLIP, which include the number of cities from 5 to 48 cities. These data sets are only used to compare the performance of algorithms. These studies will focus on the Johor areas, and there are a total of 12 spaces involved in these studies. For methodology, this study is based on traveling assessment problem and only considers one vehicles to visit all locations along the journey. It defines as the shortest total distance traversed by visiting all cities series-wise and then returning to the deposit. In the models of dynamic programming and genetic algorithm, data collected based on the distance traveled and total time spent were written in metric form and applied into modeling of these two methods using Python. The process of dynamic programming is followed by this step, and the process of genetic algorithm is summarized in this slide. After obtaining the delivery route with genetic algorithms and dynamic programming, some of the assumptions of TSP must be checked. Assumptions of TSP in this study is defined as the delivery route is begun from the courier company. All the locations has been visited actually once and travel is back to the initial phase. There are four comparisons that were conducted based on the results of total delivery distance, total time spent, and the running time of algorithms. The comparisons are delivery route based on the distance for both methods, delivery route based on different periods for both methods, and delivery routes based on the time by the best method. And these three comparisons were conducted with the primary data, and the last comparisons of performance of algorithms on different size of dataset is based on the secondary data to order the performance of algorithms for small cities to large cities. In the last comparisons, the error and learning times of the algorithms were also computed to average the performance of the proposed algorithms. Next, result and discussion. In the comparisons of delivery route based on distance travel, the shorter distance is obtained from dynamic programming. Then, in the comparisons of delivery route based on time, it can be seen that the total distance by dynamic programming is shorter than genetic algorithms in all periods. So, of the delivery routes selected, each times are taken from dynamic programming. Since 3 a.m. spent the least total time spent and 8 a.m. spent the most time spent, it can be concluded that the delivery route at 3 p.m. is the most suitable period for delivering and 8 a.m. is not suitable for delivering. After that, in the comparisons of algorithms, performance on different size of dataset, it can be clearly shown that the shorter distance are obtained from dynamic programming, and the execution times of dynamic programming is faster than the genetic algorithms in the data set of 5 cities. Besides, the genetic algorithms can generate optimal solutions in large datasets, while dynamic programming can only be sourced in programs with less than 20 cities. The result indicates that the best solutions obtained by dynamic programming is the same as the optimal solution. So, the quality solutions obtained by the dynamic programming is better than genetic algorithm. So the conclusion is The bannings on transportation rule benefit the plant nursery company to transport plants in the shorter distance in the shorter time. Different algorithms will generate different delivery routes based on different factors. Genetic algorithm can generate good or approximate solutions for large problems, while the dynamic programming can generate solutions within the shortest execution time, but only small problems can be obtained. And the dynamic programming is the best algorithm for solving the small traveling segments problems.